Okay, it's time for the first episode of the year of Tips and Tricks, and we're going to look at problems number 1, 5, 45, and 46. And I'm not going to finish or do them for you guys, but you have the opportunity to just kind of see how I'm setting up the problem and how I'm going through it, and then you can check and see if your method looks about the same. I promise later today I'll be posting the answers to the problems so that you can check your work. So the first problem for number 1, we're basically testing to see if this formula works. Now they say that period t is in times units. That's another way of saying that it's in seconds. Okay, so time is the period's measured in seconds because it's a time. The 2 pi I'm going to ignore because it doesn't affect my units at all. Length is measured in meters because it's a specific distance. And acceleration due to gravity is meters per second squared because it's a very specific acceleration. And that is getting square rooted. Okay, the whole thing's getting square rooted. So in order to undo this square root, I'm going to have to square this side. So I'm left with second squared is equal to meters divided by meters squared. Okay. From there, it shouldn't be too hard to make the last possible cancels and to find out that seconds do in fact equal seconds, or seconds squared do in fact equal seconds squared. Okay. Number 5. Number 5 is probably the grossest problem I can give you when it comes to these units of measure, right? So they were nice enough to tell you that this is the formula. That force is measured in kilogram meter per second squared. You're solving for whatever units g is. Mass is measured in kilograms. And r is actually the distance between two objects, so that's measured in meters. That's being squared. Okay? So if I'm looking at this, I've got kilogram meters per second squared is equal to g times kilograms squared meters squared. So now you're going to want to move this stuff around, right? You're going to want to multiply by meters squared. You're going to want to divide both sides by kilograms squared, and whatever you are left over with, that is going to be your units for g. Okay. All right, so for 45. For 45, you're supposed to find the length of the unknown side. Oh man, that's super blurry. Here we go. Well, you guys have the problem in front of you, right? We're supposed to find the length of the unknown side, find the tangent of theta, and we're supposed to find the sine of phi, okay? Phi being this angle down here, theta being this up here. You guys should just be using SOHCAHTOA for that. So again, if the first thing we're trying to do is find the length of the unknown side, I would suggest Pythagorean theorem, okay? A squared plus b squared is equal to c squared, but remember that c squared is always the hypotenuse, right? C squared is always the hypotenuse. So you're actually going to take 9 meters and stick that in for c. Then you can stick 6 in for A or B, and you're going to be in good shape. Okay? B, the tangent of theta. If theta is up here, and phi is down here, for tangent, okay, the side that you end up solving for is going to be your A, so you're going to have to solve for that in order to do the tangent. And for the sine of phi, right, you're actually using that sine again because, you know, with phi in mind, this is A theta, opposite theta. But this becomes opposite phi adjacent phi when you switch angles for C, right? When you start looking at what you're doing with phi for letter C, your opposite and your adjacent sides change up, all right? And then 46, again, that looks like a pretty standard, they give you one side, they give you an angle, find the missing side, just like the flagpole lab, okay? All right, if you guys have any more questions, again, reach out to me, send me an email. I'll be attaching answers to the original post soon, okay? Have a good one.